right, you guys. Ellipses. We're going to knock like 2 examples out. We're not going to get through all of the notes. So this assignment, we'll do more examples tomorrow. You're not going to be able to do this without practice. So when the bell rang, we were talking about major and minor axes. If I drew this ellipse right here, color-wise, which color would be the major axis? Alex. It is purple, yes. So the purple one, why do you think that one's major, common sense? It's longer, yeah. And then the minor axis would be the shorter one. There's something called foci, and those are those push pins or those stakes that we stick into the ground, take the string and to create this. Those will be somewhere on the major axis. They'll be on the major axis. They use A's and B's and C's for distances up here. The distance that's called A is from the center to one end on the major axis. So the major axis itself is a length of 2 times A, because A and A, we go out A from the center. And then the length of B, that's going to be on the minor axis. And then there's a length of C that starts at the center and just goes to the foci. Now, this entire picture could be turned so it not open, but it was longer horizontal instead. But what really matters is which way is longer, so you know which way to put the C's on. Okay? So I'm going to do some examples with this. First one is we're going to graph the following and state all the necessary information. We look at this equation, and we decide if it is in the correct graphing form, which I didn't really say when we were on that previous page. If you look at the correct graphing form, there's 2 different versions of it. I'm not stressing the fact that there's 2 different versions. If you look at the graphing form, what do you notice both of them equal, which is different than what circles equal? Both of them are 1. When we put this in the correct graphing form, you will have an equals 1 at the other side. So these look a lot like circles, but there's not a radius on the other side. There's a 1, and that radius that was there is divided in here. So when we look at this first example, it doesn't say equals 1, so it's not in the correct form yet. So in order to make it say equals 1, we divide everything by 9. And we have x squared over 9 plus y squared equals 1. So in the correct form, that's what it's going to look like. If I have y squared by itself, that's really over what number? 1. We'll start with the center. The center is the same way you do the center for circle. Where's the center? Those of you, the 7 of you that turned in your circle assignment, where's the center? 0, 0. There's my center. Then my major vertices, my minor vertices, and my foci all go off of the center. The major vertices, we have to use the bigger denominator. Out of these 2 denominators, which one's bigger? The 9. So in the directions, it's referring to the bigger one as a squared, and the smaller one, it's calling b squared. So the bigger one is a squared, 9. I mean, you just look at the bigger one's 9. The bigger one is under which letter? X. This is telling us it's going to be bigger on the x side. To know how far you go, you square root a squared. So a. It is going to be a plus and a minus number because we're going to square root 9. Plus minus what number? 3. So that's going to be our a value. That's telling us on the x's, because it's under the x, on the x's we're going to go right 3 and left 3. We can do that by looking at the picture starting at 0 and counting 3 and putting a dot. We can also do that by looking at the ordered pair and just adding and subtracting 3 to the x part of the ordered pair. It's really your choice which way you want to do it. Sometimes I do it this way and check it that way. You will list the vertices, -3, 0, 3, 0. You will list the vertices as ordered pairs. So those are the major vertices. The minor vertices go off of the smaller number. The smaller number is the b squared. That's 1. It's under y. So I first have to square root b squared. So I get plus minus b equals plus minus 1. And I have to add that 1 and subtract that 1 from the variable that's underneath. So from the y value in the center. I have to add and subtract 1 from the center, up and down. So we will have 0, -1, and 0, 1. On the graph, 0, -1, and 0, 1. Question?
Like the row guide ever be like diagonals?
Okay. They're, let me rephrase that. Yes, but we aren't going to do any of that. Okay? We're doing horizontal, vertical, and that's it. Okay? When you go to do your Desmos project, I had a lot of people that wanted an ellipse that turns, and there's ways to figure it out using the internet to figure it out, but we're not going to actually learn it. Okay. So I can draw my ellipse now. Try to not make it look like a egg or a football as much as you can. They don't have points at the ends of them, they round. And then we need to find our foci. To find the foci, we do a squared minus b squared equals c squared. And then the foci uses the c value. So a squared minus b squared equals c squared should sound familiar. Fully not. Like Pythagorean theorem, but it's not. You're subtracting it instead. This is how you find the foci. And our a squared is the full 9. The b squared is 1. And we're left with 8. I don't want c squared, I want c. So we're going to square root both sides. And we get plus minus what? 2 radical 2, right. We get square root 8, and then we simplify that. So we get plus minus 2 radical 2. If I'm taking the time to go over that it is that one, then I probably want it simplified, okay? So if you can simplify it, simplify it. Now that value gets added to the center in the same direction that my major axis goes. So is this going to be horizontal or vertical adding? Horizontal, okay? It's the same way that my major axis went. So I just go over here to my center and I'm going to add or subtract 2 radical 2 to the x value. And my foci will be at, let's see if I can write clear enough, -2 radical 2, 0, and 2 radical 2, 0. I didn't graph them, but I do need to plot them. How am I going to plot that? How would you plot 2 radical 2? How would you do it? How would you do it?
Just a little bit more than 2.
Yes. It's actually closer to something else. Like square root of 8 is really close to square root of 9. So I wouldn't say just a little bit more than 2. I'd say the opposite. Well, say just a little bit less than 3. I have a more accurate way of graphing it. How would you do it? Jacob, how would you do it? No, you don't bring one of those to class. Hint. Yeah, just type in like 2 radical 2 or type in square root of 8 in the calculator. It's about 2.8. And how accurate really can we be when it's that close? Graph as close as you can to 2.8. I want to see it graphed, so we need an approximation. So if you don't have a calculator, I hope that is really close to 30. Okay. Not just picking on you. You also don't know calculators, right? You don't have to tell me, I already know. And that's what we have to do for graphing ellipses. We're going to do one more, which is not going to be enough for you to go home and be like, oh, nice, entire assignment. So we're not going to grade this assignment tomorrow. We'll grade it on block day. But I'm going to do one more example with you.
So it's due block day.
Yes. Good. Just because we didn't have enough time to finish all the examples. Okay, so we're going to look at this example. Is it in the correct form? Yes. So where's the center? +1, -3. Plot it. 1, -3, center. Just like you found the center of the circle. Center of ellipse, same way. Major vertices. We look for the bigger denominator. Which one's bigger? So 36 is going to be that a squared. It's the bigger number. And it's under which variable? It's under y. So the major vertices, we're going to be adding and subtracting 6 to the y's. So here at -3, I'm going to add and subtract 6. So I will have a point at 1, -9, and 1, +3. Or I can go over to my picture, and I can go from the center, up 6, from the center, down 6. I just did the same thing with numbers and with a graph. Yes, Seth?
36 and a squared.
Yeah, that's a squared, but then the vertices we use a to move it. Okay?
So, what'd you do with the 36?
Square rooted it.
Okay.
Plus minus square rooted it. Because that tells me how far out from the center to go. Okay? Just like when we did the radius with circles, we square rooted the radius, or the r squared. We square rooted it to tell you how far out to go, only this time we're not going the same amount. We're doing 2 different amounts. So it's very similar. Minor vertices are going to be the smaller one. So if I square root plus minus square root 25, which is my b squared, I get plus minus what? 5. And I'm going to add that to, it's under the x, so I'm going to add that to the x. Plus minus 5 to that 1. So 1 minus 5 is -4, and we keep the -3. And then 1 plus 5 is 6, and we keep the -3. I can also do it on the graph. Go 5 to the left, 5 to the right. So this is the ellipse, and then I still have to find the foci. Just trying to connect these without making it look like an egg or a football. Oh, that one was ugly. Review the last one there. All right, so the foci we use a squared minus b squared equals c squared. So we do the bigger number, 36 minus 25 equals c squared. So that's 11. So my c value is going to be plus minus square root 11. Which center point do I add that to? Do I add it to the x's or the y's? Or do we not know yet? Alex, do you know?
The Y's.
Yes. Why?
Because the major axis is on the Y.
Right. So we're going to add it to the y values because it goes in the direction as the major. I do need to. Well, I'm going to write the foci with square root 11, but I do need to know approximately what that is to graph it. So I'm going to add it to the y. Square root 11 does not add with negative 3, like can't combine them. So I'm just going to have 1 comma negative 3 minus square root 11 and 1 comma negative 3 plus square root 11. So that's how I'm going to write my foci. Anybody type in square root 11? I feel like it is. What? Oh, you did it on here? Oh, okay. 3.3-ish? I think you're right. I mean, obviously if you did it, it's right. So it's about 3.3. So that goes from the center, 3.3. Or you could type in all negative 3 minus square root 11 and graph that ordered pair. I just like to go off the center. So that's what it look like. It's going to have the 4 dots, the center dot, the 4 dots around it, and then the 2 foci. So what I would encourage you to do is maybe try a couple questions for your assignment. If you don't do anything between now and Thursday, you're going to have a ton to do on Thursday. And you're probably going to forget it. So the assignment is on Canvas, but I'm also going to, what do I mean by Thursday? I don't mean Thursday. It's due on Thursday. By tomorrow, I don't know what day it is apparently. By tomorrow, try, by Tuesday, try a couple of these. And then come in tomorrow, see what questions you have, or if you're like, that was really easy, I had no problems at all. Great, we'll just add on to that. But we will be adding on, you can see in your notes, there's quite a bit more we didn't get to. And the ones we didn't get to, you have to like complete the square also. Or you have to write the equation from given information. That's the stuff we didn't get to. So this is the assignment, and then, again, not due till block day. Due on block day. Got it?